There are forces in our world that we cannot see. They shape the flight of birds, and they guide the lonely whale across vast oceans. They are the unseen currents of our planet, a silent language spoken by the earth itself. But what if, long ago, ancient peoples learned to understand this language? What if they learned not only to hear it, but to speak it? The question we explore today is a remarkable one, bordering on the fantastical yet rooted in tangible evidence found buried in the African soil. Could it be that ancient African civilizations, with their profound knowledge of metallurgy and the natural world, mastered a form of magnetic technology, perhaps even creating shields against unseen forces? This is not a story of myth or legend alone, though it is informed by them. It is a journey into the heart of archaeology, into the ruins of magnificent cities and the remnants of astonishingly advanced industries. We will look at what has been found, what it might mean, and how much more there is yet to uncover. The idea of magnetic shields in antiquity seems to belong to the realm of fiction, yet the clues are there, scattered across the continent. They are subtle, easily missed, and demand that we look at the past with fresh eyes, prepared to question our assumptions about the limits of ancient technological prowess. It begins with a simple, intriguing possibility. The Earth is whispering its secrets, and it is time we learn to listen. In the high plateau of southern Africa stands a breathtaking monument to a forgotten power, Great Zimbabwe. Its name means Great Houses of Stone. Its walls were built with astonishing precision, without a speck of mortar. They have stood for centuries. This was the capital of a vast empire, a hub of trade connected to the far-flung ports of the Indian Ocean. For years, colonial historians refused to believe native Africans built it. But it's not just the stonework that captivates us. It's what lies within and around these silent walls. Archaeologists unearthed a wealth of artifacts, intricate goldwork, pottery from China, pottery from Persia, and evidence of extensive iron smelting. The people were master builders. They were skilled metallurgists. They worked iron on a significant scale. And here we find our first intriguing clue. Among the discoveries, stones. Many were naturally magnetic lodestones, found in contexts suggesting special significance. Not discarded rocks. Collected, perhaps revered, for their strange, invisible power to attract iron. What purpose did these magnetic stones serve? Oral traditions from the Shona people, descendants of this civilization, speak of sacred power in certain stones. They speak of the city's spiritual connection to the land. While these stories don't mention magnetic shields explicitly, they hint at a deep understanding of natural forces. Could lodestones have been used in rituals? Or were they part of a practical technological application? The stones, plus advanced metallurgy, force us to consider new possibilities. The city's scale and social sophistication show capacity for complex projects. Building the walls required immense organization, engineering skill, a deep understanding of geometry and physics. Is it a leap to imagine the same curiosity applied to those stones? The evidence is circumstantial. Intriguing puzzle pieces, not a complete picture. Our journey now takes us to West Africa, to a time long before the great medieval empires of Ghana, Mali here. Scattered across the landscape from Senegal, Chad, we find evidence of one of the most remarkable industrial revolutions in human history. Beginning around 1500 BC, West African peoples developed iron smelting technology that was, in some respects, unique in the ancient world. Their furnaces, tall, chimney-like structures made of clay, were capable of reaching incredibly high temperatures. This was not the simple blacksmithing of a small village. This was a widespread, highly sophisticated industry that produced metal of exceptional quality. The key to their success was a process known as preheating. They designed furnaces with clever air intake systems, forcing air through channels heated by the furnace itself before the air entered the main chamber. That innovation let them reach temperatures high enough to produce steel, a feat European smiths wouldn't match for another 1,000 years. In that context, magnetism becomes compelling. When iron ore is heated to extreme temperatures with carbon, it turns into iron and steel. But as the molten iron cools, it can record the Earth's magnetic field. These advanced furnaces would have inadvertently created magnetized metal. Ancient smiths would almost certainly have noticed. They would have seen tools sticking together and fine iron filings aligning around a freshly cooled bloom. This wasn't a one-off. It would have been consistent and repeatable. For people attuned to material properties, it's hard to believe they'd ignore it. Oral histories and spiritual traditions across West Africa often cast smiths as having almost magical powers, masters of both fire and earth. Could that reputation come in part from manipulating magnetism? Born in their furnaces, they were effectively creating magnets on an industrial scale, but it establishes a society with raw materials and the intellectual framework to begin exploring magnetism. It would be to turn our backs on a potential chapter of human history that is as astonishing as it is profound. So let us begin with an open mind and a sense of wonder, to examine the proof that we may have overlooked for far too long, hidden in plain sight, waiting for the right questions to be asked. The earth is whispering its secrets, and it is time we learned to listen. Following the life-giving Nile southward, we leave Egypt behind and enter the lands of ancient Nubia, the realm of the Kushite kings. Here, nestled between the river's cataracts, rose the city of Meroe. For centuries, Meroe was a powerhouse of Africa, a thriving metropolis famed for its steep-sided pyramids and for its immense industrial might. Called the Birmingham of ancient Africa, vast mounds of slag still surround the ancient city, proof of an industry running for nearly 1,000 years. The Meroitic people were masters of iron. Their location gave them abundant iron ore and the wood to fuel countless furnaces. They developed sophisticated furnaces to make high-grade iron and steel. This metal built their economy, and it forged their military power. They controlled territories and trade across Africa and reached into the Roman world. The volume of production shows a systemized, optimized metallurgy. Here we find advanced technology and possible magnetic discovery. Smelting at scale would have produced huge amounts of magnetized iron. Every tool, every weapon, every piece of metal. To grasp the potential of these ancient technologies, we must first understand the force at the heart of our inquiry: magnetism. Magnetism is a fundamental force of nature created by the movement of electric charges. The molten iron core, deep within the Earth, generates a vast magnetic field. That field surrounds our world like an invisible shield. It protects us from harmful solar radiation. It provides the basis for navigation. It is the force that makes a compass needle point north. It has been a silent guide for navigators for centuries. Certain materials, most notably iron, have a special relationship with magnetism. Each iron atom acts like a tiny magnet. In ordinary iron, those atoms point in random directions, cancelling out. Iron atoms randomly oriented. Iron atoms align under a magnetic field when heated. If you expose iron to a strong magnetic field while it's very hot, the atoms can be persuaded to align in the same direction. When the iron cools, that alignment can lock in place. The metal becomes a permanent magnet. It will have a north pole, it will have a south pole. This is what could happen in advanced furnaces in Africa. How might that be used to create something like a shield? A magnetic shield doesn't have to be a solid barrier. It could work by deflecting other magnetic forces or by deflecting charged particles. Imagine a series of carefully shaped, oriented magnets arranged in a specific pattern. Their fields combine. They can form a larger, unified field. That field could be shaped into a protective bubble or into a directional barrier. It could push on other magnetic objects. It could pull on other magnetic objects. It could influence the flow of charged particles like solar wind. The science is plausible with simple materials, The key isn't a futuristic power source. The key is a deep, intuitive understanding of shaping and arranging fields. It would require precise craftsmanship, forging iron into specific shapes, and trial and error to discover the optimal arrangement. Ancient African metallurgists had the forging skill in abundance, given their consistent, large-scale creation of magnetized iron. While the evidence we have explored is tantalizing, we must approach it with scientific rigor and acknowledge what we do not know. The most significant gap in our theory is the absence of a complete, recognizable device. Archaeologists have found countless tools, weapons, pieces of smelted iron, but they have not yet unearthed an artifact that is unambiguously a magnetic shield or a component of one. We have found the potential ingredients: the magnetized iron, but not the finished recipe, the smoking gun. Without that smoking gun, the idea remains a hypothesis, not a proven fact. Furthermore, the magnetic properties of existing artifacts are not fully studied. Extensive laboratory testing is needed at scale. We need samples of slag, tools, iron blooms from Great Zimbabwe, Meroe, and the smelting centers of West Africa and measure their magnetic signatures. The story of Africa's ancient metallurgists is far from over. What we have uncovered so far presents us with a profound and exciting challenge. To move from intriguing possibility to scientific certainty, we must embark on a new phase of discovery, one that unites different fields of knowledge. The way forward requires close collaboration: archaeologists who unearth the past, physicists who analyze invisible forces in ancient materials. Imagine teams working together at these historic sites: a modern physicist and a traditional elder examining an iron artifact, using magnetometers to map magnetic fields of entire structures, applying modern analytical techniques to individual artifacts. This scientific investigation must go hand in hand with respect for local knowledge, oral histories, traditions. We must engage with community elders, historians, listening with humility to stories passed down through generations. These narratives may contain the context we need to understand purpose. They can provide the why to the scientists' how, guiding research and helping interpret findings in a way that honors the creators. This exploration is not about proving one sensational claim. It's about broadening our understanding of the human story and diverse technological paths. Whether or not they built magnetic shields, the investigation will reveal their advanced metallurgical skills and their relationship with the natural world. Every furnace excavated, every tool analyzed, every story recorded, each adds a richer layer to our shared history, challenging old notions of the ancient world. The whispers of the earth, first heard in the ruins of Great Zimbabwe, are growing louder. Evidence from the furnaces of West Africa, the slag heaps of Meroe. It invites us not to jump to conclusions, but to ask bigger questions and look more deeply. Embrace this invitation with curiosity, with rigor, with a spirit of collaboration. The next chapter in this remarkable story is waiting to be written. It is a task for all of us together to uncover the full, incredible scope of human ingenuity across the planet.